Now let's see the products of sines and cosines and how we can express them as sums and differences. So it's basically the opposite of what we did before, but it's the same logic. You can get either one by the same process. So it says that if you have different combinations of sines and cosines, so for example, sine p plus sine q or sine p minus sine q, cos p plus cos q or cos p minus cos q, you can see all of these are just differentiated by either the change in the trigonometric function, so it's either a sine or a cosine, and with the addition and subtraction signs between them, right? So how do these change the products? Well, there are very subtle differences like before. You'll have to deal with p plus q by 2 and p minus q by 2. Just remember that. And you'll have to see what function they are in. The functions are the only things that change in the product side of the equation, right? So for example, if you have sine p plus sine q and if you have sine p minus sine q, what's the difference eventually in the product side? Well, you can see that only the positive and negative signs are changing. So on the right hand side, the only thing that changes is the function. Instead of sine p plus q, you have cos p plus q, and instead of cos p minus q, you have sine p minus q. And so these are all the very, very subtle differences that exist in such questions. And yeah, you just need to basically just see the logic behind all of this, see all the subtle differences, and you'll easily be able to memorize all of these. But we're not concerned with that. We're more concerned with the question that is over here, right? So yeah, again, if you need to relate this back to the sums and differences of sine and cosine and how they're converted into the products, you just remember that p over here is a alpha plus beta and q is alpha minus beta, and you'll easily be able to understand why we get this, right? But again, all of these are related by the fundamental theorem, right? So yeah, here's a question. It says that sine 5 theta plus sine 3 theta. We need to express this sum as products. Okay, so we have already been given this, right? Sine alpha plus sine beta is equal to 2 sine alpha plus beta by 2 into cos alpha minus beta by 2, right? This was in the previous slide. And so you can replace this alpha over here with 5 theta and this beta over here with 3 theta. And you'll replace them over here as well. And so you get this. Now just add 5 theta plus 3 theta over here and 5 theta minus 3 theta over here. And you get this, okay? Obviously, because this entire term, if you write it down, it becomes, sorry, not this, it becomes sine 8 theta by 2. And so you can cancel this out and it's just eventually equal to sine 4 theta, right? And similarly over here, this becomes cos theta. And so you have 2 sine 4 theta cos theta, and this is how you converted this sum of trigonometric functions into a product term.